In chemistry, we use the SI or metric system of units. Because you guys might not be as familiar with these units, I thought that I would include this introduction to what they are and how you convert between the different sizes of units. Here's a collection of 6 of the base or fundamental SI units. We've got mass as defined by the kilogram, length by the meter, temperature by the Kelvin, time by the second, electric current by the ampere, which will become more important in the spring when we study electrochemistry, and we have the quantity of substance expressed as moles. This value and this unit will become very near and dear to your heart. These units are defined by IUPAC. IUPAC is the international governing body of chemistry as a profession. Each of these, except for the kilogram, is defined according to invariable physical constants. This is done so that we're not dependent on a particular object being a meter long. We can just link it to something that could be observed anywhere in the universe. The kilogram, though it's due for an overhaul, is still currently a particular sphere made out of a platinum iridium alloy. If you want to hear more, come talk to me. It's a pretty cool story. The only other base unit that I haven't mentioned is the candela. The candela is a measure of light intensity, so we don't tend to use it a whole lot as chemists. From these units, all of the other units are derived. For instance, the speed would be measured in kilometers per hour, or pressure is measured in 1 Newton per square meter, and a Newton itself is another derived unit, so you can get really complex with these things fast. The only other unit that I'm going to mention right now is the liter. This is a common measure of volume. Now, technically, according to the SI system, we would be expressing volumes as cubic meters, but it turns out that the liter is a much more convenient unit to use, and you're going to see a lot of it. 1 liter is about the size of a quart. Each of those base units can be modified by the addition of one of these prefixes. The reason we do this is because depending on how large or small a value we're measuring, we want to be able to use a unit that's kind of comparable in size. For instance, you wouldn't want to measure the distance to California, something more conveniently measured in kilometers, in a unit that is more suited to measuring the width of a human hair, like the micrometer. I have now highlighted in blue the most common prefixes that you'll run across. Kilo is as in kilogram or kilometer. That kilo stands for 10 to the third. It tells you that there are 1,000 of the base unit in this compound unit. So there's 1,000 meters, 10 to the third meters, in 1 kilometer. Now it's same for centi. Centi means 10 to the minus 2. There are 100 centimeters in 1 meter. Milli, 10 to the minus third. We'll see this one on grams, meters, and liters just because it's so handy. Micro, we'll see on either liters. Microliters are a volume frequently used in biochemistry, or in micrometers, which is a wavelength of light that is a bit longer than we can see. Nano, 10 to the minus 9th, you'll really only see in front of meters, as the nanometer is a really convenient unit for talking about the wavelength of visible light. Let's look at some examples of converting between these units. Let's convert 2.77 grams to micrograms. We start with our 2.77 grams, and then we know that 1 gram is 1 times 10 to the 6th micrograms. You can go back and check that chart on the previous page. We are going from a larger unit to a smaller unit, so we're going to need more of those smaller units to count the same value. Therefore, whenever you go from a large unit to a small unit, the number itself should increase, which is what we see here, 2.77 times 10 to the 6th micrograms. Let's go the other way. We're going to convert 313.4 milligrams to grams. We start with our 313.4 milligrams. We know from the prefix that there's going to be 1 times 10 to the third, or 1,000 milligrams in 1 gram. Crunch that. We get 3.314 times 10 to the minus 1 grams. Note, we've gone from a smaller unit to a larger unit. Therefore, we have to go from a larger number to a smaller number. We need fewer units of the larger unit to count the same value. If you need a refresher on how to work with scientific notation, take a look at your textbook. In the back, there's a few appendices. APP 1 is the math appendix. It's got a nice little overview. Let's try something that's a little more challenging. We're going to convert 596.8 liters to cubic meters. This is actually a very big unit. We're going to start by saying some simple things that will make our lives easier. From prefixes, we know that 1 liter is 1,000 milliliters. However, I bet you didn't know, 1 milliliter is also 1 cubic centimeter. I tuck that one away just in case you need it. Combining these two, we can say that 1 liter equals 1,000 cubic centimeters. All right, we're now in this kind of cubic length unit sort of thing we need, but how do we get from centimeters cubed to meters cubed? It's not as straightforward as you might think. Let's start with one dimension. I have here a line. It is 1 meter long. It is also 1 times 10 to the 2 centimeters long. If we add the second dimension, this box is 1 meter on each side. Its area is therefore 1 times 1, 1 meter squared. But its area is also 1 times 10 to the 2 times 1 times 10 to the 2 centimeters squared, or 1 times 10 to the 4th centimeters squared. That's an exponential increase. What happens if we add the third dimension? I have a box. It is 1 meter on each side. Its volume is 1 times 1 times 1 equals 1 meter cubed. But its volume is also 1 times 10 to the 2 cubed, centimeters cubed, or 1 times 10 to the 6th centimeters cubed. So here's our final conversion factor we need. We string it all together in some train tracks. 596.8 liters, we say 1 liter becomes 1,000 cubic centimeters. Then we say that 1 times 10 to the 6th cubic centimeters becomes 1 cubic meter. Crunch, crunch, crunch. 5.968 times 10 to the minus 1 cubic meters. So there you go. As long as you keep an eye on your units and an eye on your conversion factors, you can't go wrong. If you do hit a rough patch, you've got the study pods, you've got my office hours. Otherwise, guys, I will see you on Wednesday.